anyone tell me what blue line mainly indicates, what red line is indicates, and what this pink line is indicate? How can anyone explain any idea about this fan curve?
Good afternoon, sir. Karthik this side.
Yeah.
सर इस ग्राफ में जो ब्लैक लाइन और जो रेड लाइन है ये फैन कर्व्स शो कर रही है डिफरेंट आरपीएम्स एंड ये जो पिंक लाइन जो है ये सिस्टम रेजिस्टेंस के कर्व को शो कर रही है। ये जो डार्सी वेस्टलैग इक्वेशन है उसके इक्वेशन से ये पैराबोलिक प्रोफाइल बनता है इस पिंक वाली लाइन का। और जहाँ पे ये सिस्टम कर्व और फैन कर्व इंटरसेक्ट करता है वही हमारा ऑपरेटिंग पॉइंट रहता है। और ये जो ब्लू वाली लाइन से ये हमारी एफिशिएंसी कर्व की लाइन से।
Very good, very good, very good, Karthik. Because in this curve, when you have to deal, because why the fan curve is the most important thing. Because maximum 30 to 40% energy conservation mainly generally take place through the fan curve. Okay. Now, because first, can anyone tell me what is the fan head? What is the fan head?
The difference in outlet static pressure minus.
You don't have to say,
pressure.
because I am to asking other people who are in the, because there are 20 participants in the this. So, can anyone tell me, Sachin, what is the fan curve of one fan head?
Sir, fan head is basically the difference between the out static pressure and the inlet static pressure. This is known as the fan head.
Very good, very good. So fan head क्या होता है? What is the fan head? When you talking about the fan head part, fan head generally comes about the fan outlet static pressure. Fan head, when I talking about the fan outlet, like static fan outlet minus fan inlet. Okay. If someone is able to learn this fan curve na, okay, then he's the master in the cement industry. Okay. The fan head, when you're talking about the fan head is equals to fan outlet minus fan inlet. Okay. So this is my static pressure. Static pressure means this is my fan head. Because whatever I am showing here, suppose whatever I am showing here, this what in this part in the left side, this is the fan head, and this y-axis, this is the fan head, and x-axis we are showing the volumetric flow rate. Okay. Now, Karthik has already discussed how to get this curve. Okay. And second, first, there are 2-3 things in the fan curve, and there are so many misconceptions in the fan curve. First, how to apply this fan curve. Okay. And then first we have to understand the concept. So in this presentation, what we have to see, first we have to understand the concept. Then its application. Application means suppose your fan efficiency. Okay, can anyone tell me those who already replied, they don't reply other than what is the fan efficiency? Can anyone tell me? It's very simple. I already put so many videos. Still, your people are not able to know fan efficiency. What is the fan efficiency? Simple language. Don't say any formula.
Good afternoon, sir. Fan efficiency is mechanical power divided by electrical power.
Very good. Now, fan efficiency means mechanical power divided by electrical power. So, can anyone tell me what is the mechanical power?
Sir, mechanical power
flow into fan head.
Huh?
Flow into fan head.
Very good. Fan up now divided by electrical power. Okay. Now, when you have to describe this is my fan head. This fan efficiency formula. Now, when you are able to know, because generally when you have to understand this concept of fan curve, now as someone has already explained, this mechanical power equals to fan head. Fan head, I say the delta P. Okay, this is my delta P in my y-axis, and this is the flow. Okay, I can say that is the Q. Okay. So delta P into Q equals to my mechanical power, which is shown in the kilowatt. Now, can anyone tell me this is the application of mechanical power? Suppose my fan, because when you have to learn the interesting part of this fan, this is my stack. Okay. This is my stack. and I am getting the static pressure of minus 15 here. Inlet I am getting minus 600, minus 200, you can say that minus 200 suppose. Now, suppose if I increase the stack height, okay, so what will happen upon the fan head? Whether it will increase, decrease, or remain same? Tell me.
Sir, I guess the fan head will increase because the fan has to apply more power.
Wait. Someone has tell me कि if I increase the stack height, fan head will delta P increase.
Oh, sir,
Okay.
delta P decrease because of natural drafts over here.
So someone will tell me delta P increase, or someone is saying the delta P decrease. It means the step still whatever I am saying that still the concept is not clear. When you got this, so what I told the delta P equals to what is delta P? Delta P equals to fan outlet minus fan inlet. So fan outlet, how much we are getting? Fan outlet we are getting minus 15. Okay. Initially and minus 200. Okay. So this is the negative value. If I increase further, again the delta P will decrease. Okay. Now, if the delta P will decrease, what about the mechanical power? It will also decrease.
Yes.
Samjhe? So the most
Yes.
important thing in the point ki without concluding, without thinking, you don't give any answer. So I ask ki if we increase the stack height, what will happen? If we increase the stack height, my delta P will decrease. If my delta P will decrease, automatically my mechanical power will decrease. If my mechanical power will decrease, so automatically my fan power will decrease. In that case, I will able to save the power. Okay. So generally, this is the concept of natural draft. Now, can anyone tell me ki what now someone is saying that ki sir is mainly discussing why in the so much detail. Because after learning the fan ka people, student or participants in whatever we have engineers, we are not able to implement in the practical life. Okay. Suppose you are able to learn so many things, but at the end of the day, if you are not able to implement in the practical life, then there is no meaning. Okay. So can anyone tell me ki what is the natural draft? And what factors mainly depend upon the natural draft?
It is caused by the density difference between the ambient air and
Yeah,
the air in
density
the
difference or
stack.
what density difference?
Sir,
Suppose this is my cooler stack, okay, and here I'm getting the temperature of 300 degrees centigrade, okay.
Yes, sir.
So generally what will happen, density differences between the ambient as well as inside the system. If the difference between
Yes.
the two temperature, ambient as well as inside the system is very high, the density difference is also high. Due to this density differences, the pressure will create. Okay. So what will happen when you increase the height? So your natural draft also increase. Okay. If the natural draft will increase, automatically fan has to do less work. Okay, because the same work, because the total work as per the total work is always constant. The same work is transferred to the stack. Okay, means कि दो लोग हैं, एक आदमी है उसके आगे एक और आदमी है, तो वो वर्क shifted to the another person. So same concept you have to learn about the natural draft. Now this is all about the mechanical power. Then we have to understand the concept of stack. Okay. Now we have to understand the fan efficiency curve of the mechanical power. Now another question someone is asking about the fan loss. They ask the question in the fan loss. So what is the fan loss? So generally when we're talking about the fan loss equals to N1 by N2 equals to Q1 by Q2. It means your RPM is directly proportional to flow. It means if if I increase the RPM in the same, if suppose if I increase the RPM 10%, then my flow will also increase with the respect to the 10%. But when we're talking about the head, head is equals to N1 by N2 equals to whole square equals to H1 by H2. Now Can anyone tell me how to get the power? Because power, what is the function of power? P into Q. If I multiply by
Sir,
Q
power is
into
in cube.
yeah. So if I multiply equation 1 Q into H1 by H2, Q is my flow and H1 by H2 is Q is my flow and H is the head. If I multiply Q into H, so power formula is equals to N1 by N2 whole Q. So that's why you can see that this curve is mainly N1 by N2 का whole cube. It means power is proportional to cube. And N is directly proportional to Q. So Q is directly proportional to the P cube. So whatever the flow with respect to flow and what respect to power, you are getting this curve. Okay. Now, when you have to put the RPM and you have to put the power in the Excel sheet, you will able to generate this power consumption curve. Similarly, when you have to draw this N1, N2, this N1 by N2, Q1 and Q put the Excel, so it will generate the respect to the flow. And similarly, when you have to put the static pressure, how you will get the static pressure with respect to flow, it mainly changes with the N1 by N2 square. Now, so someone is discussed in the initially when I asked you what is the operating point. So can anyone tell me what is the operating point in the fan curve? Can anyone tell me what is the operating point in the fan curve? Very simple, yaar. This is static pressure, this is fan head. What is this? This is the system resistance. The system resistance and this flow of this operating, this is the operating point. What you are saying that this is the operating point. So generally when we have to select the fan, so what we have to select? We have to select the fan and we have to design the fan at the one point only. Suppose in WHRS case, the fan is designed. Suppose if you operate the fan without WHRS and if you have to operate with WHRS, in which you have to operate with WHRS, in that case, your temperature is very low. Okay, at the end, whatever the fan inlet temperature will get at very low. But without WHRS, you will get the fan inlet temperature very high. So generally, when we have to design the any fan, so we have to select only one point. So this is my first operating point when we this is system resistance curve and this curve is now what will happen if this is the blue line is showing the efficiency part. If I go inside this fan, so what will happen? My efficiency will deviate. So generally what will happen in some cases, what we have seen ki design efficiency and operating efficiency, so much deviation. Because your operating point and design point, suppose you have to design at this point, okay, but your operating point here comes this side. So what will happen? Your efficiency curve lies here. So automatically your efficiency will down. So generally when we have to select suppose you want to retrofit the fan with higher efficiency. So generally what we have to do, we have to select the fan. We have to take the safety margin only 10%. Suppose we need the operating point is 7 lakh meter cube. In that case, design I will take maximum to maximum 7,70,000 meter cube. Because if there's so much deviation with the design with operating, automatically your fan efficiency will, what will happen? Your fan efficiency will be deteriorated. Okay. So this is the one of the part you have to understand. Second thing you have to keep in your mind. Suppose now, can anyone tell me this is my flow and this is my RPM, or this is my head, sorry. Now can anyone tell me if suppose on the same RPM, if I increase the flow, okay, so what will happen with the pressure? Suppose this is my X1 flow I am getting now. Okay. Now if I go to X2 part, so what will happen at the same RPM? If I go to X2 part, so and I will draw the line like this. So what will happen? This pressure head or system resistance will decrease and automatically my flow will increase. It means generally what you have seen when you have to remove damper. Okay, when you have to remove the damper in the this fans, automatically what will happen? Your system resistance will decrease. Automatically, your fan flow will increase. Can anyone tell me ki when the when the CO formation take place due to coating? So in that case, what we have to do? We have to increase the kiln fan RPM. Preheater fan RPM. Why? Because on that same RPM, we are getting the low flow due to high resistance. Okay, so this is the concept. Similarly, suppose now if I get the flow like this. Suppose my flow is this is my now suppose my flow is become x3. Now what will happen at the same RPM when I x3 is intersecting with this curve, and then what will be getting? New system resistance, which means if the system resistance will increase, the flow will decrease. But one thing you always keep in mind is fan curve is always applicable at the constant RPM. Okay, it not be applicable for different RPM. It means at the same RPM, if the flow will increase, automatically your system resistance will decrease. Now, can anyone tell me? Okay, I will give you one question. Okay, now then I will able to know ki people you all able to understand the concept of this fan curve or not. Okay, now very simple. How to apply this fan curve? Suppose write down. Suppose your kiln RPM is presently 900. Okay. Suppose your kiln RPM is 900 and flow you are getting around 4 lakh meter cube per hour. Okay. Kiln RPM is 900 and flow you will get the 400 and you know the existing power. At 950 or 960, whatever RPM, what power will you will get? How will you get it? Can anyone tell me? Can
Sir, can
anyone
you
tell
please
me?
repeat the question?
Wait, I am writing down this. Suppose my initial RPM is 900 RPM. Okay. Suppose 900 RPM. And you are getting the flow around 4 lakh meter cube per hour. Okay. 4 lakh meter cube per hour. Suppose you are getting the flow something. Okay. And whatever the power is generating, use whatever the power, X power, whatever. Now, if I increase the RPM 990 or 980, suppose. Okay. So what about my new power? What about my new flow? How will you get it?
Affinity
Sir,
loss.
it will be according to the formula P1 divided by P2 is equal to
And
N2
how can
divided
you
by
apply the
N1.
formula? That's why I'm saying, na, suppose formula is okay. Suppose I am talking about the formula part. Suppose formula is Q1 by Q2 equals to N1 by N2. Now, generally, okay, as Mr. Samit Soni is already joined, I don't want to take so much time. So generally Q1 by Q2 equals to N1 by 2 N2. But if you apply this formula directly in this equation, okay, so you will not get any number. What you have to suppose, you have to apply this formula Q1 by Q2 equals to N1 by N2 in the fan curve. So what you have to do, first you have to take the fan curve of the same fan. Suppose any of the plant, you have to take the kiln of the same fan. Then this N Q1 they have given, okay, and N1 they have given, okay. From this formula, Q1 by Q2 N1, you have to first calculate the head, okay, and then whatever the head you are getting, then from head you have to put in the second formula of N1 by N2 equals to whole square equals to H1 by H2. It means whatever the value you will get from this formula, you have to take from the curve. And again, the same equation you have to apply in the same curve. Okay. Generally, what happened? We have to apply directly. This is not the right thing. We have to directly apply the fan law on directly in the this formula. So what we have to do? We have to put this value in the formula, but what we have get the value from the fan curve. Now, suppose this is a Q1 they have given, N1 they have given. With respect to Q1, N1, you have to take the head from the curve also. Okay, you cannot directly take from the formula. Then you have to interpret the formula in the curve. So this is a method to get the right value, because you don't know about the system resistance, because when you have to design this fan curve, there are so many experimental, there are so many factors they have to consider. So we don't know. So we can't apply the formula directly. We have to apply the formula on the curve itself. Then we will get able to know the value. So anyone have any doubt about this fan curve, they can ask. Otherwise, we have to discuss about the ball mill optimization section.
Sir, I have a question. Sir, if I want to keep the same flow of the system, suppose 1,75,000 cubic meter per hour, but
Okay.
and also for the same flow, if I keep the RPM the same, and the delta P of the system will increase or not, sir? For example, let me give you a simple example. If there are if there are more bends in a system, there are
Okay.
more bends in the system, and I want to keep the same flow of 1,75,000 cubic meter per hour. So will the pressure drop uh, decrease
No, no.
or
First,
increase?
no. Suppose you are, I first, what you are saying that key fan in the series.
Sir, consider the case of a coal mill, the hot
Okay.
gas fan,
Yeah. Okay. Okay.
the
Coal
hot
mill.
gas
Okay.
fan.
If I take the case of coal mill. Okay.
Yes, sir.
Hmm.
Suppose if I have to reduce the number of bends in between the hot gas fan, that is the booster fan,
Ah.
and the
Okay,
coal
okay,
mill.
I
So,
got your point. If what will happen if you maintain the same coal fan RPM, if you reduce the number of bands, what will happen? Automatically your pressure drop will decrease. If your pressure drop will decrease, automatically what will happen? Your system resistance will decrease. So automatically your flow will increase. Okay, so your flow will increase. So generally, what will happen in that case? Suppose 50 mm WG, you reduce the pressure drop. So in that case, how much saving you will get? So in that case, what we have to do? You have to reduce the fan RPM to maintain the same nozzle running velocity. If you reduce the fan RPM, automatically you will get the benefit in the saving. So how will you get the saving? Suppose you reduce the 50 mm WG to the 50 divided by fan head into coal mill fan power, you will get the your answer. So maybe in the next Saturday, I will take detail about the this part about this fan curve. Even you can ask so many questions, because generally fan curve applications come when you have to retrofit or when you have to do the pressure drop calculations. But the concept of fan curve should be applicable at the constant RPM. Again, I'm repeating the same thing. If you are, suppose you're running the coal clinker mill, if your DP is higher side at 86% RPM. So when the DPL is higher side, what we have to do? We have to uh, increase the fan RPM to maintain the same dust loading. Because if you increase the DP, what will happen? Automatically, my system resistance will increase. So cement industry is very simple. Don't take very tension. Everything is mainly dependent upon the velocity, and and then due to velocity, the pressure head will change. Okay, so there is no concept of draft in the cement plant. Everything is dependent upon the volume and velocity. So today, again, if anyone any doubt, they can ask. They could put in the group if I'm able to know, because I'm now introducing our Mr. Samir Soni. He's the expert in the this thing.
सर एक डाउट था मेरा सर.
Yeah. बोलो बोलो
सर
जल्दी
ये
बोलो.
स्टैक की हाइट इंक्रीज करने की लिमिट कुछ सर ये स्टैक की हाइट इंक्रीज करने की लिमिट कुछ रहती है क्या?
जो
स्टैक हाइट
स्टैक
करने
ये,
का
हाँ,
अगर हमें
वेरी
बेनिफिट
गुड
मिल जाए.
क्वेश्चन. एक्चुअली क्या होता है कि स्टैक का एक फॉर्मूला होता है जो बैरोमेट्रिक प्रेशर का रहता है. सो हम लोग क्या करते हैं, बैरोमेट्रिक प्रेशर के फॉर्मूले में जो स्टैक का हाइट होता है, ठीक है ना, मैं आपको डाल दूंगा ग्रुप में, उसमें हम लोग डिफरेंस देखते हैं. क्या होता है, एक पर्टिकुलर लिमिट पे आने के बाद नेचुरल ड्राफ्ट इतना नहीं बढ़ता है. ठीक है ना, हर चीज की एक लिमिट होती है.
ओके.
तो जब हम लोगों को जो डिफरेंस मिलता है हाइट का, और उसके करस्पॉन्डिंग जो हम लोग इन्वेस्टमेंट कर रहे हैं, अगर उसमें पे बैक नहीं आ रहा है, ठीक है ना, तो हम वो प्रपोजल हम लोग नहीं करते. समझ में आया?
ओके सर.
उसमें एक जो डेंसिटी डिफरेंस का एक फॉर्मूला होता है स्टैक हाइट का, वो मैं डाल दूंगा ग्रुप में. उसके हिसाब से हम लोग कैलकुलेशन करते हैं. अगर वो डिफरेंस नहीं आएगा, इफ यू आर नॉट गेटिंग एनी डिफरेंस, इन दैट केस यू डोंट हैव टू स्पेंड द मनी. ओके, ये है.
ओके.
सो नाउ आई एम दिस